Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem-solving skill in mathematics. First, we will analyze the problem on hand to find the related concepts. Then, using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in mathematics. In this video tutorial, we will discuss the method of expanding a determinant of order 3 and the important properties of determinants. For better understanding, we will use the double subscript notation for the elements of the determinant such that the first subscript is the row number and the second subscript is the column number. Hence, Aij denotes the element of the ith row and jth column. Consider the determinant whose first row is A11, A12 and A13. Second row is A21, A22 and A23, and the third row is A31, A32 and A33. Expanding the determinant along the first row, we get A11 into its minor determinant minus A12 into its minor determinant plus A13 into its minor determinant. We observe that the signs of the terms are positive, negative and positive. Next, we have expanded the determinant along the first column. Now we will discuss about minors and cofactors. Minor of an element Aij of a determinant is the determinant obtained by deleting the ith row and jth column of the determinant. It is represented by Mij. The minors of all the 9 elements are noted here. We observe that M11 is the minor of the element A11. It is important to note that none of the elements of M11 has row number 1 or column number 1. This rule is also applicable to the other 8 minors. Now for the cofactors. Cofactor of an element Aij of the determinant is denoted as Aij, which is equal to minus 1 to the power I plus j into Mij. It may be noted that Aij is positive when I plus j is even and negative when I plus j is odd. Hence, we get the 9 cofactors are alternately positive and negative. We have noted the 9 cofactors here for ready reference. Now for expanding the determinant in terms of the cofactors of its elements. First, we have expanded the determinant along the first row. The result may be expressed as the sum of the products of elements of the first row with their corresponding cofactors. We observe that in cofactor notation all the terms are positive. It is because the negative sign, wherever applicable, is present in the cofactor itself. Similarly, the determinant can be expanded along C1 also. Now we will discuss the properties of determinants. The first property states that if the rows and columns of a determinant are interchanged, then the value of the determinant remains unchanged. It may be noted that we can write R1, R2 and R3 respectively as C1, C2 and C3 without changing the value of the determinant. The rows of determinant delta 1 are the same as the corresponding columns of delta 2. Therefore, delta 1 is equal to delta 2. It can be seen that expanding delta 1 along R1 and delta 2 along C1 will produce the same result. Now for the second property. It states that if any two rows or columns of a determinant are interchanged, then the sign of the determinant changes. We have obtained the determinant delta 2 by interchanging R1 and R2 of determinant delta 1. Now we will expand delta 1 along R1 and delta 2 along R2. We observe that the signs of each term of delta 2 are opposite of the corresponding terms of delta 1. Therefore, we have delta 2 is equal to minus delta 1. The third property states that if any two rows or columns of a determinant are identical, then the value of the determinant is 0. Consider the determinant delta. We observe that the rows R1 and R2 are identical. Now, interchanging R1 and R2, we should obtain minus delta. We observe that delta is equal to minus delta. This implies delta is equal to 0. The fourth property states that if each element of a row or column of a determinant is multiplied by a constant, then the value of the determinant gets multiplied by that constant. In the example, each element of the first row of determinant delta is multiplied by a constant k to obtain delta dash. Expanding delta dash along R1, we observe that its value is equal to that of k delta. The fifth property states that if all the elements of a row or column of a determinant are expressed as the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. In the example, each element of the first row of the determinant on the LHS is the sum of two terms. Hence, it can be expressed as the sum of two determinants shown on the RHS. Here we have expanded LHS along R1, which is equal to A1 plus X1 into its minor minus A2 plus X2 into its minor plus A3 plus X3 into its minor. Then we have separated the terms containing A1, A2 and A3 and X1, X2 and X3. This gives the two determinants on the RHS. The sixth property states that if to each element of a row or column of a determinant the equimultiples of the corresponding elements of another row or column are added, then the value of the determinant remains unchanged. In the example, each element of R2 of the determinant on LHS is multiplied by K and then added to the corresponding elements of R1 to obtain the determinant on the RHS, such that the value of the two determinants are equal. Here we have expressed the determinant on the RHS as the sum of two determinants. We observe that each element of R1 of the second determinant has a common factor K, which is taken out. Now we observe that R1 and R2 of the second determinant are identical, therefore its value is 0, which gives the first determinant on the RHS is equal to the determinant on the LHS.